Alright, so I'm gonna do a crash course on double and triple integrals. So you can order, or you can reverse order differentials. For example, what does that mean? That means that f of x comma y dx dy is equal to the double integral of f of x y dy dx. What matters is if there's a variable limit and which integral you do first. The order of the differentials does not tell you which integral to do first. You look at the limits. So if any of the integrals have a variable limit, you must perform the integration first. So let's see this. You have the integral from x equals 0 to 1 and the integral from y equals 0 to x squared, f of x comma y dx dy. So that is equal to the integral of x equals 0 to 1 of the integral from y equals 0 to x squared f of x comma y dy dx. So let's go to another example. Let's say we have the integral from x equals 0 to 4y and the integral from y equals negative 8 to 8 of f of x comma y dx dy is equal to the integral y equals negative 8 to 8 of the integral from x equals 0 to 4y f of x y dx dy. So in this example, x being the upper limit is a function of y. Since the x limit has a variable, you must integrate over x before integrating over y. Let's do another example. Let's do the integral from x equals 0 to 2, and the integral from y equals negative 1 to 1 f of x comma y dx dy. All the limits are constant, so in this case you can do the integral in any order. So that's equivalent to this. The integral from x equals 0 to 2 of the integral from y equals negative 1 to 1 of f of x comma y dy dx, which is equivalent to the integral of y equals negative 1 to 1 all of the integral from x equals 0 to 2 f of x comma y dx dy. So when integrating over one variable, treat the other independent variables as constants. When integrating over x, treat y and z as the same as you would treat any other constant, etc. So let's do an actual example now. given the integral from x equals 0 to 2 and the integral from y equals 0 to x squared, all of x cubed times y dx dy. Since the upper limit y is a function of x, you must carry out the y integration first. So when we're integrating over y, you treat x like any other constant. So you can factor x cubed out of the y integral, but be careful not to pull x cubed out of the x integral. So you can just say Okay, given another problem we have because all the limits are constants, you can integrate however you want. So we can rewrite that as